just doing like the same thing that they did in the notes? Is that still helpful?
Yes, absolutely.
Okay. That leaves you more problems to do. I hope it doesn't stop you from watching the notes, because I think it's very beneficial to see it twice from two different points of view. You know, if someone tells you once and someone tells you twice, you're way more likely to remember the second time. I would strongly encourage you to still do the notes. So, the three things that you can't have in a domain is you cannot have a zero on the bottom. So that's what this one's getting at. So you can't have, I guess I'm supposed to write that over here. No zero on the bottom. So if I gave you this one, what x value would make the bottom equal to 0? -1. So then you can write the domain a few different ways. You can say all real numbers such that x is not equal to -1. That's one way. So you're saying every single number is fine unless it's -1. You could say everything's fine from infinity up to -1 and from -1 to infinity. But notice I put parentheses there, not brackets, so I'm not actually including the -1. Or you could say x is less than -1 and x is greater than -1. And again, I didn't put like the or equal to, so I'm saying the same thing. Every single number is fine to plug into this, except -1. I don't care which way you write it. The AP test typically uses that. And I think in your book, it even does it a little different than that. Does it have like that U?
Yeah.
That's the same thing as a comma. It's just like a list. All of these values are okay to plug in. So you can plug in anything from here, or, that means or, the U. You can plug in anything from here. So there's kind of two issues. Like one, can you figure out what the domain is? And then two, can you write it the correct way? Any of the four of those are fine. I would say this is the most common. But you should, ideally, be able to like know how they're saying and go back and forth between them. On top of it, okay? Second one, so you cannot take the square root of a negative. No, square root negative. The square root of negative is an imaginary number, and we're not getting into imaginary numbers in this class. Can you take the square root of 0? Yeah. The square root of 0 is 0. Because what's 0 squared? It's 0. So the reason that matters is the stuff inside the parentheses. Does it have to be greater than, I'm sorry, stuff inside the square root. Does that have to be greater than 0 or greater than or equal to 0? It has to be greater than or equal to 0. Because if this stuff comes out to 0, it's fine. Because I would take the square root of 0. The square root of 0 is 0. So this is what has to be true. The stuff in there has to be 0 or higher. So if I solve that, I get like 7x is greater than or equal to -3. And then I divide by 7, so it doesn't come up in this one. But it's been a while since you guys have done like inequalities. Remember what happens if you divide by a negative? You gotta change the sign. So I'll do that in a second. So this is x is greater than or equal to -3/7. Or it would look like this. -3/7 to infinity. Why did I put a bracket there instead of a parenthesis? Because I want to include that because it can be equal. Or x is greater than or equal to -3/7. Those are all the exact, wait, that's literally the same thing. Alright, those two. But if you have a negative, just to review that, if I have like -3x is less than or equal to 9, give me an x value that makes that true. I kind of want to like show you why it works and how it works. 1? Sure. So if I plug in 1, is that true? Yeah. Well, if I divide it by -3, and I didn't flip the sign, right? So I'm saying I'm doing this wrong, this is not the right way, does that value of 1 that we said is supposed to work still work? It doesn't. So how can I make sure that it still works? You have to flip the sign. So if you multiply or divide by a negative, that's the situation you're in. And you have to remember to change that inequality. Okay. And then the third one is you cannot take the natural log of a negative. No natural log of, you actually can't take the natural log of 0 either. So no natural log of 0 or negative.
They just say greater than 0.
So yeah, the stuff that you're taking the natural log of has to be greater than 0. That's the same thing, just like phrasing it differently. So that is different than the absolute value, or than the square root. So like for this one, if the stuff inside the square root is 0, are you okay? Yes. So I can take the square root of 0. For this, if the stuff inside is equal to 0, am I okay? No, because I can't take the natural log of 0. So this 2x plus 1 has to be greater than 0, not greater than or equal to. Then if I solve that, so that means 2x is greater than negative 1. Do I have to switch the sign around in this scenario?
No.
I do not, because I divided by a positive, not by a negative. So I get x is greater than negative 1/2, or that would be like everything from negative 1/2 to infinity, and I made this a parenthesis. Why? I don't want to include that negative 1/2. So that's like the three things that you're looking for. So every problem you see, is there a chance that I can get a 0 on the bottom? Is there a chance I can take the square root of negative? And multiple things can happen in the same problem. Is there a chance that the natural log is 0 or negative? And we have to work around those things. Okay, erase this, or is that one still red? Will you try to copy that stuff? Yeah. Lots of distracting when you're writing, but a couple weeks ago, last week, people were complaining because they had to pay like $300 to park at Saline for consortium. That can't be true.
No, so for consortium, you can like apply to get, like, if you apply, they'll give you a pass for free. But like, if you go to Saline, you do have like you have to buy a parking pass. Like, and I don't think
I got that.
I didn't hear $300. I heard like 60 or something like that.
Okay.
$300
So
Yeah,
the
they,
people
like,
that
make
were
it
saying that didn't apply for the pass.
Probably. Yeah, it's not like, from what I've heard, it's not super hard to get a pass though. Like, if you have half a legit reason.
Like if you exist.
Yeah.
Yeah. Like the consortium, it just seems like it should be automatic. But
Yeah. The thing is, they want you to ride the bus. Is the thing. So like, you have to give like a somewhat decent
work around that.
Yeah.
But like they're saying, you get back faster when you're on the bus. Like,
Yeah,
would you be back right now if you weren't on the bus? If you were on the bus?
Well, the bus actually, it's funny you bring this up today because the bus actually got here really early today for some reason.
Oh, okay.
But normally we meet the bus by a couple minutes every day.
Yeah. Which, so you're like trying to get back faster.
Yeah, that's why. Yeah, we're not supposed to ride with people, but we always kind of try to get around.
But it's for like an academic reason. It's not like.
Yeah.
Okay. Let me go through a few of these. Probably all 5 of them, actually. So for this one, you got like 3 things to look at. Is it possible I get a 0 on the bottom? Yeah. What would x have to be? X have to be 0. So I know that x cannot be 0. Is it possible that number 1 take the square root of negative? No, because there's no square roots and there's no natural logs either, right? So that's my answer. So you can write it 3 ways. You can say all real numbers as long as x is not equal to 0. Look at that circle. You can't even tell where I started and stopped.
Wow.
That is beautiful. I just want to like stop.
It is recorded.
I'm gonna retire.
Was that game on the board when you tried to like draw?
Oh yeah. Yeah.
Did it for like 10 minutes.
It's like soothing. Okay, or you could say negative infinity to 0, 0 to infinity, or you could say x is less than 0, x is greater than 0. Those are all the same thing. It's just the idea that every single number is fine above 0 and below 0, but not actually 0. Notice too, like some people might look at this, I don't know if anyone did this, but you could like cancel an x out of each of those, and it would just say x minus 1. And then if you look at this, does it look like there's a discontinuity? Like, is there 0 on the bottom of x minus 1? No, so don't like reduce or simplify or cancel before you start looking at this. Because if you do that, if you simplify this first, you're going to miss the discontinuity with those things. Fair enough? Alright. Number 2, can I get a 0 on the bottom? Yeah, so I know x can't be 0. And could I end up, there's no natural logs, but could I end up with a negative square root? I could. So along with x can't be 0, x plus 5 has to be greater than 0 or greater than or equal to 0? Because if the stuff inside that is 0, it's totally fine. The square root of 0 is 0. So x plus 5 has to be greater than or equal to 0. So x has to be greater than or equal to negative 5. And then I've got these two things to worry about. So so I'm going to say negative 5 to 0, and 0 to infinity. Or x is greater than or equal to negative 5, as long as x is not equal to 0. So you kind of wrote it right there with those two things. But these two are also.
If it were a test, how would you
I would accept both. I'm not going to tell you like you can do it 3 ways on the test. Sorry, you didn't guess the one I was thinking.
No, I just didn't know if like for like the 3 you'd be like, alright, I want this one this way, this one this way, this one this way.
No, and there's like, I can't even say like the AP test always uses this one because they go back, they want to make sure you know all of them, sort of thing. So I wouldn't, it's like tempting to rely on one, right? Just get used to one. But just realize you will have to be able to like answer multiple choice questions in all 3 forms. Number 3. So a couple things on here. There's no LNs. But the first thing is that x has to be greater than or equal to 0. Right? The number inside of the square root has to be 0 or bigger, or we can't take the square root of it. The second thing is the bottom can't equal 0. So I gotta find out where does that happen. So where does 2 minus the square root of x equal 0? So I gotta solve that. Because if this is true, then it's 5 over 0 and I'm stuck. I'd probably add the square root of x to the other side. And then how do I solve that? Square both sides, so 4 equals x. Which really means like x can't equal 4, right? So x is greater than or equal to 0 as long as x doesn't equal 4. Or you could say like 0 to 4 and 4 to infinity. So either one of those are valid answers.
Wait, why do you need the x has to be greater than or equal to 0? It's like if you plugged in 0, it would be like subtracted by 2, right?
If I put 0 in here, it'd be 2 minus 0, which is like 5 halves, so that works, that's fine. Are you talking about the square root? So there's two things. That number that you put inside of the square root has to be positive, or 0, because we can't take the square root of negative.
Oh, I see. Okay.
But then like overall, that whole bottom can't together equal 0, so there's like 2 parts to it.
Okay, I see.
Good. Question or yours? Any questions on 1, 2, or 3 then? So 3 is a little more. I think 3 is probably 4. 4 and 5 are probably the trickier ones. So you cannot take the natural log of a negative number, and if the bottom of that fraction equals 0, we're stuck too. So first of all, what number can't go in for x? So x cannot be 4. Because if it were, I'm saying what's the natural log of 4 over 0, and we're saying what's the natural log of undefined, and that's just doesn't make any sense. The second issue is the stuff in here has to be positive. So the easiest way to kind of think through these, in my opinion, is I'm going to solve the top. Set the top equal to 0, set the bottom equal to 0. If I set the top equal to 0, what do I get? 0, right? Set the bottom equal to 0, I get 4. So I'm making like a little number line here. This kind of separates all the numbers into 3 types of numbers. You're either smaller than 0, you're either between 0 and 4, or you're bigger than 4. And then I'm going to check like a representative point from each of these sections in here and see if it's okay or not. So for example, if I plug in negative 1, so my representative point for this section is x equals negative 1. So that would end up with natural log of negative 1 over negative 1 minus 4. Is that okay? That is okay, right? Because this would essentially be what's the natural log of 1/5, and that's a positive number, so we're all good. So this part is okay. And if you plugged in any other number less than 0, it would be the same exact thing. -2, -1,000,000, -infinity. You'd come out with this every time. That's what this like splitting on does. Pick a number from this section. Say x equals 2. If I asked you for the natural log of 2 over 2 minus 4, is that okay? It's not, because now you get a negative, right? So this section's no good. And if you plugged in 1 or 3, like the same thing would happen. Pick one from over here. So let's say ln, let's say 8. 8 over 8 minus 4. Is that okay? It is. So that section's good. And any number you picked from that section would work. So the two sections I have to describe are this section and this section. I also have to keep in mind that x cannot equal 4. So I'm going to say negative infinity to 0. And 4 to infinity. So that's that one. That's that one. It doesn't that automatically take care of the fact that x can't equal 4? It just kind of fit in there. Because the 4 doesn't have a bracket. Right? Questions on that? 5. So we got to look for two things now. First, we have to look for jump discontinuities. So at 0, if it's going to be continuous, at 0, when I plug in 0, I have to get the same thing. And then at, so for this one, it's 0. Let's just start there. So if I plug 0 to the top, what do I get? I get negative 1/7. If I plug 0 to the bottom, or the middle, I get negative 3/7. Right? So is there a discontinuity at x equals 0? There is. So I'm just kind of like starting to, I got to summarize it later, but I know there's a discontinuity at x equals 0. Let's check these two. What number would I plug into both of those to check that? Plug in 3, because that's like the end point for both of them. So if I plug in 3 to the top one here, 3 over 3 minus 7, I get negative 3/4. I plug 3 into the bottom one, I get 6 over negative 8, so I get negative 6/8. But those are the same, right? So is there a discontinuity at x equals 3? There's not, because these two rows come together. So I've got to jump here, and then this is fine. But I didn't even get into like fractions and square roots and all that. I still have to do that. This one doesn't have any issues. I can't have a 0 on the bottom. That's a 7. So you can't make it a 0. There's no ln's, there's no square roots. So this one's all good. This one, x can't be what? For that middle. X can't be 7. But if x were 7, would the middle one be the one that we were using? It wouldn't. So it doesn't matter. X can be 7. So let me explain that again. It's tempting to look at this and go, okay, 3 over x minus 7. So x minus 7 equals 0. So the bottom can't be 7. So I got to write down x does not equal 7. But that's not actually true, because this equation only applies when x is between 0 and 3. So the 7 would actually go into this bottom one, and it doesn't cause a problem in the bottom. So you not only have to look for problems, you have to make sure the problem fits with where that equation is active, I guess. This bottom one here. So if the bottom were equal to 0, so if I do 4x minus 20 equals 0, on the bottom, and I solve that, I get x equals 5. So x equals 5 is a problem. Is x equals 5 in the portion of the equation where it would cause the problem? It is, so then we have to worry about it. So there's another discontinuity at x equals 5. So then I got to write this in like a fancier notation. So I can either say all real numbers except when x equals 0 and x equals 5. Or I could do like negative infinity to 0, 0 to 5, and 5 to infinity. And both those are fine. I don't care which one you write. If it's a free response, the AP test doesn't either. Multiple choice wise, you just match up. So yeah.
They don't care if you do the all real ones, even though it asks where it's continuous, so you don't need the interval.
So this says it is continuous everywhere. That's what this means.
Yeah.
Except for these two spots. So you're still answering the question. I think in like in college, I remember learning such that. I think it's this. time to work on the rest of it. I think there was one. 13's hard, but I want you to do it.
Yeah.
It's not a skill.
No.
So yeah, the rest of it is, let me know if I can help. Answers on there. I forgot. Were there questions on 11? I don't want to skip over them. Shall I pull it up? I'm pulling it. You were solid?
Connor and I were not solid for a long time.
Did you get to solid?
We did, because we were plugging in K's for X's, so we weren't on like number 11. We were working on it together, and we were plugging in X values as K's, so they weren't matching up. Because the answer says that
Oh, so instead of plugging it in for X, you plugged it in for K?
we were getting like these.
Gotcha.
So we were walking up here to ask you 7th hour on Friday. I'm like, wait, Connor, are we plugging these in right? And then
You figured it out on the way.
it was half an hour of confusion.
So any questions I can go over on 11? Or 1.11? Okay. So go ahead and get to work. Same idea. Appreciate it. So finish up this, do the 1.13. You'll notice we're not too far away from like the test. It only goes to 1.16. 1.3 Tuesday, 1.4 Wednesday, 1.5 Thursday, 1.6 Friday, and then it'll be like review test. So it's coming fairly quickly.